Hello, today we're going to be going through the Roman numeral kata in Clojure using TDD. So let's begin by describing our test. These are going to convert Roman numerals to Arabic numerals, and the most simple case of this happening is probably just converting I to 1. So let's write our first test. We have this function maybe called as Arabic, and it parses I as 1. Sure enough, we get a compilation error. There is no as Arabic function. Let's go back and define that. So get rid of that boilerplate. Define as Arabic. It takes in a number, and the smallest amount of code to make this pass, simply return 1. Now, what is the next most complicated case of this? Well, let's parse 2, right? If we can parse 2 tally marks, surely we can, or if we can parse 1 tally mark, surely we can parse 2. There we go. Sure enough, fails as expected because we haven't actually implemented anything here. But what we're doing with the tally marks is we're essentially just counting them. So let's take our string here, let's convert it to a sequence that gets its characters, and let's just return the number of characters. So the next most complicated instance of this might be counting to 3, right? If we can count to 2, surely we can count to 3. And sure enough, our test passes. So let's take a second here. Instead of having these each be individual tests, let's put them in a single one. So if something is less than 3, we just, we parse it as a tally mark, essentially. And we can go ahead and clean up those. Perfect. Our test still passes. So what is the next most complicated case here? Well, let's take a number other than I, right? Let's take 5. So it should parse 5 as Arabic V. Sure enough, we get 1 because V has 1 character. So we need to actually do some mapping here. We need to finally create the association between each character and its numerical value. So we can define I as 1, and we can map V to 5. And then what we can do is we can take each of those characters in our sequence, and we can thread them through and take each of those characters, map them to the value in digits, and then add them all up. Sure enough, it does what we want it to do. And we can do this as well for maybe x and 10, so it should equal 10 as Arabic x. Okay, it doesn't exist yet. Let's add it to the map. Okay, x is 10. Perfect. There are a lot of instances of parsing numbers like this, though, right? We've got V, we've got X, we've got L, C, D, M. So let's go ahead and write a test for all the single character numerals here. So sure enough, that 50 test fails. Let's go ahead, map L to 50, can map C to 100, D to 500, D to 500, and M to 1000. Perfect. All right, our single character numeral test passes. So now let's do something slightly more complicated. Let's do some addition-based numerals, something like maybe 6, when we have a V followed by an I. We need to sum those up. Sure enough, it works. We can try with another one, maybe 11 as Arabic XI. Perfect. Because we're just going through each of the characters and we're summing them up anyway. Just for good measure, we could add another test, 120 as Arabic, give that a CXX. Perfect. Okay. But now let's address the subtraction-based numerals. This is where it gets a little bit more complicated. So for something like 4, which is IV, we need to recognize that I is less than V, and therefore it's being modified with V coming to the right. So instead of simply adding up all of our values, let's pass in an anonymous function here to the reduce. And we do want to add 2 things. We want to add the second value, for instance 5V, but depending on whether or not the value that comes before it is greater than or less than that value, we want to add or subtract. So if the second value, V, is greater than the first value, I, we want to return a coefficient of -1, otherwise return a coefficient of 1. So this will in effect make it so that if the second value is greater, then we subtract the first value. And that was a little bit ugly, so let's break that out into its own function. Maybe call that coefficient. Maybe subtotal coefficient would be better. And we can break that out right up there. Define subtotal coefficient, give it a first and a second value, and toss those guys in there. Perfect. And we can see if this works with other similar subtraction-based numerals as well. Maybe 9 as Arabic IX. Perfect. Another example might be 40 as Arabic, let's see, XL. These are not our most complicated case though. We have our addition-based numerals and our subtraction-based numerals, but we also have numerals that follow both of these rules. So something like 24, we might have XX and then IV, right? XX for 20, IV for 4, but when we use our current algorithm, we get 26, not 24. So why might this be happening? Well, let's take a look at our string here, XXIV. Reading this from left to right, we have an X as a 10, and then another X that's also a 10, and then an I. Well, I is less than 20, so we simply read it as 21. And same thing with 5. 5 is less than 21, so we read it now as 26. So let's comment that out for a second and rethink our algorithm. So instead of reading it from left to right, what if we read it from right to left, where we can basically count on our numbers getting larger in value as we go across. So instead of checking the first with respect to the second, let's add the first value, now the last value, with the reverse of our sequence. What's happening now? It's reading our I and our I, making that 2, and then reading our 1 after it. Well, since the 1 is less than the 2, it is subtracting it and giving us 1. This is not what we want. So what might we do about this? Well, when we have consecutive identical characters, let's just consolidate those. So let's partition by identity and then map the reduction of each of these values with addition. Perfect. It behaves just the way that it was previously. And now when we uncomment our test with the mixed addition and subtraction based numerals, it works just as we expected it. For good measure, let's go in and add in maybe 1900, that's another good one, as Arabic MCM. And sure enough, it works just as we had expected it. So that is the Roman numeral kata. Thank you very much for joining me, and I will see you in the next video.